right, so we'll keep practicing because the only way you get better at integration is honestly by doing a lot of problems. All right, so yet again, for the first technique in this problem, I'm going to use U-substitution. I mean, honestly, I don't know if many of these problems will not involve U-substitution of some kind. That's one of the reasons it's so important to learn it in Calc 1. So U is rather obviously cosine because cosine is nested inside some other function down here in the denominator. And the derivative of cosine is negative sine of x dx, which of course we have sine of x dx there, so we really want negative du. Beautiful. Okay, so that means that there's technique number 1, and I can rewrite my lovely integral as the integral of negative du over u squared plus u. Now, what are we going to do there? Well, let's see here. How about we separate it out? I mean, for one thing, let's take that negative out, put it out in front. Why not? Makes things a little bit easier. And then I'm thinking this is 1 over u times u plus 1 du. And hopefully you're thinking what I'm thinking. Fraction, big denominator. I'd like to be able to separate it into pieces. Partial fractions, right? So technique number 1 gets us here. And now we need technique number 2. So this was U sub for technique number 1. Technique number 2 is going to be, oh, so much fun. Actually, it won't be too bad because it's a pretty small one. So number 2 will be partial fractions. We need to separate out our factored denominator. And the only way to do that is to rewrite it with partial fractions. So let's write what that was. It was 1 over u times u plus 1. And that would be a over u plus b over u plus 1. Luckily, they're both linear terms, which is really nice. Linear factors, I should say, in the denominator. The quadratic ones can get pretty crazy, especially if there's a repeated one. That would be awful. All right, so then what do we know? We multiply everything by u times u plus 1 in our heads. Over here, we're left with 1 equals a times u plus 1 plus b times u. Because over here the u plus 1s would cancel, over here the u's would cancel. And so we're left with 1. Well, we could, at this point, we could either use technique number 1 or method number 1, which would be substituting in values. So you'd let u equal 0, let u equals 1. That would work. You could also just distribute. You could say, oh, okay, 1 equals a u plus a plus bu. So notice, if you look at those and line them up here, I'm using method number 2 just because I feel like you need to get more practice with it. So if I put the two u terms together, a plus b, you'll notice there's no u over here. So that means a plus b has to be equal to 0, and a, which is the constant term, is 1. Huh, that's nice. Lovely. Okay, so a is 1. No work involved. And a plus b, right here, has to be 0 because there's no u term. So a plus b has to be equal to 0, but I know that a is 1, which means b is negative 1. Okay, so that means that I could rewrite it as 1 over 1, or 1 over u, excuse me, 1 over u. I got my colors mixed up here. Sorry. 1 over u plus negative 1, so I guess I could say minus 1, minus 1 over u plus 1. That would be my rewrite of that fraction. So I realized it wasn't really equal to anything, so I should at least write what it was equal to. Okay, so now I can take that and go substitute back into the integral. Okay, so that would be technique number 2. So right here, using technique number 2, we would rewrite our integral. There's still a negative out in front, so I'm going to put that negative right there. And then integral, and then it was 1 over u minus, or plus, if you will, a negative 1 over u plus 1. And then there's still the du sitting out there. Now, this whole negative in front thing is a little weird. So I think what I'm going to do is I'm going to separate this, or rewrite this. So I'm going to put the blue one, which was negative 1, I'm going to distribute that negative and make it positive 1 over u plus 1 minus 1 over u du. I'm just rearranging the order so that I don't have to deal with the negative in front of the entire integral. It was just easier for me to distribute that negative. And now we integrate. And both of these, luckily for us, are extremely easy integrals. This is the natural log of the absolute value of u plus 1 minus the natural log of the absolute value of u plus c. Now you're not done, because the problem wasn't given to you in terms of u. The problem was given to you in terms of x. So you need to go back and put back in what u was. So u was equal to the cosine of x. It's right here. So it's the cosine of x plus 1 minus the natural log of the absolute value of the cosine of x. Now, if you're feeling really excited, you could play with your logarithm properties. Oop, I forgot to close off my absolute value there. And make it the natural log of the cosine of x plus 1 over the cosine of x. But cosine over cosine is 1, so that's the natural log of 1 plus 1 over the cosine of x, which would be the natural log of 1 plus the secant of x. And that would also be correct.